Good evening, all the engineers from Africa. This is John Elnami from Kenya. I'm actually presenting this webinar for the Midas Gen. I'm joined with my fellow director. He's actually one of the director that is in charge of both India and Africa. He's called Mr. Adrian. And apart from that one, I want to thank you once again for attending this webinar. I know it has not been easy. As I told you, most people were supposed to attend. It seems that they are trying to attend, but I know because of time, we cannot wait for them because time is money and time is gold. I know most of you have really sacrificed your time just to come and to participate on this online webinar. I want to thank you so much. And once again, I want to say that feel free if you have any question, just write the question on the question board, and at the end of this webinar or at the end of this presentation, we'll be able to respond to you. And I would like to make you to feel comfortable. I don't want you to hesitate. We're going to do the presentation and also demonstration of our software. So please just be comfortable and feel free to ask any question. And if maybe you cannot hear me also, you may also send a message. At least we may be able to respond to you. And in case you cannot even see the screen, please make sure that everything is clear on your side. And if there's any kind of a technical problem, please let us know and we'll try to respond to you. Otherwise, thank you so much. At the moment, I'm joined also with another technical engineer. So now we are 3 online. So in case of anything, we'll be able to respond to you. Well, I want to thank you, Mr. Gopinathan G, Mr. Henry Kaule, Mahendra Reddy, Mr. Peter Michael, and Sepiso Mufolo. I really want to thank you so much for taking this time. As I won't waste time, let me just go ahead and start. Well, why Midas Gen? I know most of you, maybe you're not familiarized with Midas Gen, but this actually, it's a 3D structure design software that is based on the FEM, and basically it's focusing on the designing of the building. Not only building, as I will try to demonstrate to you, we also do other type of structures such as the plant or maybe the airport, name it. So today I'll just explain briefly what is Midas Gen, and also I'll do some demonstration based on steel structure. I'll do the modeling and also the analysis up to the designing part, coming up with the result. And then if in case you have any question, please, once again, don't hesitate. Just feel free to ask us. Well, Midas Gen, as I said, is a 3D designing structure that is based on the FEM. We're going to share, as we said, why Midas Gen. So Midas Gen, I'm going to share with you based on its reliability, then based on the product itself and the service. So on the product, I'm going to actually emphasize on the practical part of it, the usability, and also the productivity and specialization. So I'm sure as I'll be covering from step to step, you'll be able actually to get the feeling of what kind of a software it is and how efficient it is and how you can apply it on the area of your project. Let's look at the practical. Well, Midas is really, it's actually a one-stop solution software. Why do I say like that one? Because it has actually the CAD interface whereby you can be able to import and export any CAD model from another software or maybe from another file to the software and be able to bring it to Midas Gen to do the analysis and also to input the load. As you can see from here, it's kind of a transfer of model from actually Tekla. I know most of you know Tekla, and also we have also the Revit. So you can imagine we have that interface with that. Not only that one, also within Midas Gen, we are actually able to model a structure based on the 2D, and also you can generate the 3D structure model after you've actually made the foundation of the 2D on the on the card. So you can see it's more practical, meaning you feel very comfortable to work with it. Not only that one, also Midas Gen has what you call the D shop. It's actually a drawing. It's one of the family program that we call the D shop. It's basically based on the drawing. You can draw as you draw from the AutoCAD and actually import the model to the Midas Gen and do the actually the input of the load and also let's say other boundary and do the analysis in Midas Gen and try to export also to other program. And not only that, Midas Gen also has what you call the report. You can actually generate a report that will help you in terms of the designing. And then apart from that one also, you can also, as you're modeling your structure, you can actually generate more structure, or maybe depending with the level that you want, and you may come up with a table, or maybe let's say you may come up with a report such as this one. Anyway, I'll explain more on this one. So this is one part of it, as we say, one-stop solution, meaning you can do everything at once. Talk about the, let's say, the import export. You can also do the modeling. You can do the analysis at the same time. So that's why we could say you don't need to actually rely on other software. You can just do everything at once. As I said before, we have the data exchange. Why? Because we have the tech, like this is a structure from Tekla. You can actually import this one to Midas Gen. You can see when you import it, we can do now you can input the load. You can also do the boundary, and also you can do the analysis and the designing with the Midas Gen. After you finish, you can export back again to Tekla. The same also apply with this one, the Revit interface also. You see, this is the model according to the Revit software. You can actually import it to Midas Gen, put the load, try to check if the load have been implied or maybe have been applied accordingly. And you can also do the analysis and the designing. And then after you've done, you can export it back. So it's actually more compatible. It means more actually practical in terms of working, especially those who are engineers. You can understand what I'm talking about. Now let's look at the diversity. Actually, Midas Gen, not only for the building, as we've seen before, you can generate very tall building. And so generating tall building, that is one part of it. But also still, we can actually also model, we can do the analysis of a stadium. For example, the Beijing National Stadium. As you remember the World Cup, that was 2002, there was a World Cup, and you see China, they actually use our software to model and to design this kind of stadium. Not only the stadium, you can also see the aquatic center. We can also do what you call the gymnasium. We can also, as a stadium also in South Korea, like the Seoul World Cup Stadium, it has actually been modeled, it has actually been analyzed and also been designed by Midas Gen. Not only that, you see many type of stadium, and also in China, you can see this kind of diagram. So you can find that it's more focusing on the power plants. You have the hangar, the airport, transmission towers, the cranes, pressure vessels, machine structure, underground structure, name it. So it's more practical. Why? Because you can use it in a diverse project, not only just building, but you can also use with other area. And I believe that most of you engineers, you understand that where we are actually, like in Africa, many people now starting like focusing on the designing of the, let's say, airport, talk about the stadium. So this will be the best software to help you in terms of easing actually the workload of modeling and also designing and do the analysis. Now let's look at the usability. Well, It's very user friendly. It's very user friendly, meaning you won't take a lot of time to learn it. Why? Now, when you look at this one, this is just the page of the software. I'll do the demonstration and try to show to you how easy it is to get to familiarize with it. Now, on my left-hand side, we call it a works tree. Now, the works tree actually it gives you the guideline, like from step to step, like what kind of step you've been actually input the data, you've been input the load or maybe the boundary. It actually shows you. So it means you can actually cross-check your work, whether you've done the right thing or not. And maybe in case there is any mistake, you can just do what you call the drag and drop. Not only that one, it has also the tax pen. You see, the tax pen give you the direction. For example, you want to do the analysis for the pushover analysis, or maybe the backlink analysis, or maybe the p-delta analysis. You just click it, and then it gives you the instruction on what to follow. Not only that, it has also what you call the online manual, whereby you can just click it. You don't need to go again to the hard copy manual. You can just click it, the online manual, and give you the guideline also on how to model, or maybe on how to do the designing part. Now, another thing that is very important and very actually essential for the engineer is what we call now the Excel report. You can bear with me that the work of the engineer without having a report is actually nothing, because you spend a lot of time. If you cannot come up with the report at the end of the day, then you feel like you've really wasted a lot of time. So Midas Gen has the compatibility of the Excel file. That means whatever model that you come up with, you'll be able to come up with this kind of the table, or maybe this kind of the table, also the diagram. So at the end of the day, it's very compatible with what you call the MS Word file. So you can choose any file that you want to do to generate your report. That's why I'm still emphasizing it's very usable. It's actually very efficient in terms of working with Midas Gen. Now, still also looking at the several features, like generating of the building, there's what you call the story drift. You need to come up with this kind of result, like you see generating the structure wizard. It has the wizard that will help you to come up with different types of result, like for example, the shear story, or maybe the shear force ratio, or the stiffness irregularity, or define the module for the multi-tower. So at the end of the day, when you are looking at the story drift, or maybe if you want to generate, let's say, a high-rise building, you'll be able to come up with the different types of result. Like you see, story related with the result, like you can have the diagram there showing the table, and also giving you also like the maximum force and the minimum force, and also checking like which sections have been applied where or not. So it means it's very actually useful. It has useful features, especially for those who are focusing on the especially the high-rise building. You are able to check once again the story drift, and also you are able to check the story shear, and also the story shear force ratio. So it means it has several types of result. I will try to show you while I'm going to demonstrate on the steel structure. Still, on the usability, we also have the boundary. Like you can see the available element type, as you can see from there. We have the wall, the plate, and the solid element. Now we can also apply the boundary, like you have the point spring boundary for the elastic and for the linear constraint. You see all these type of the boundary, and I believe that they're very essential, especially for the designing of a structure. So it means when you have this kind of a boundary, you are able to create the link between the structure, and you find that it's actually easy also to calculate the soil stiffness, as you can see from the diagram there. So to be just brief, it's very easy to actually to calculate the shear wall element, and also it has the beam end release, and then the beam end offset for the panel zone effect. So it means at the end of the day, you are able to apply the right boundary condition for the right element, or maybe the plates, or maybe the footing, just name it. Now let's look at the productivity. Well, I know most of you, if I may ask you, most of you are looking for software that is very fast to use, and then meaning fast in terms of modeling, in terms of the analysis, and also in terms of the designing process. I hope you agree with me, because if you have a software that will take a lot of time to do the modeling, it then is going to interfere with with the productivity of your project. So looking at Midas, actually, it's very fast in terms of the modeling. Why? Because it has the multi-solver, so whereby you are able to do everything at once, as I said before. So it means it has the multi-solver fronter, whereby it's very accurate in terms of the doing the analysis and the designing part. Now you can do everything at once. You can come up with the reports, as you can see from here. You can do the beam column design, and then you generate also the report. You can do the footing design, input the right data, you come up with the report also. You can do the slab and wall design. The same thing also, you can look at the result showing you the maximum and also the minimum. You can also view your structure at any angle. Still also you can see the still optimal design. So it means it's very automatic in terms of designing and also doing the model. So at the end of the day, you're able to see the optimal result. Then apart from that, I know most of you now, you're looking at this part for the code. Okay, we have different types of code. For example, we have the RC design, you can see there. We have the steel design also, the SRC design. We have the footing design, the slab design based into Eurocode. And after you've done the designing, you can come up with what you call the report, which is very essential for most of us, especially for the engineers. So talk about the code, we can cover actually any type of code depending with the request that you give to us. So it means the issue of the code, you don't need to worry about that one. As you can see, we cover like the main code that you know that for the Eurocode and the BC, also the ASHTO. So it depends anyway with the code that you're using. Now the analysis speed then, as I said before, like we have what you call the multi-frontal solver. So it's very actually accurate and fast. And not only that one, also we have the latest analysis algorithm, which is very practical in terms of coming up with the results, such as the construction stage analysis for those who are doing the high-rise building. And also you can also input the boundary and linear analysis. You can also do the pre-tension girder analysis and also the pushover analysis. So it means having the multi-frontal solver and also with the new latest algorithm, it actually doesn't take a lot of time. You can bear with me that most of the people, the software that they are using takes a lot of time. Even sometimes when you're doing the analysis, or it actually crash. But we've never experienced this kind of things in Midas Gen. And in terms of the speed, you just like it because I know, as I said before, time is money. So everyone wants to see everything is done accordingly. Then you can come up with a result like this one. So it means at the end of the day, the speed, you take actually the shortest speed, maybe like 10 minutes or maybe like less than even maybe 5 minutes. And I'll just show you while I'm going to do the demonstration. So this is what we are saying is very productive, meaning if we can actually kill time, then you can do many things at once. And then also we have also the powerful graphic. You can see from here. We have the transparency graphic, means you can come up with any type of graph depending with the like that you want. So not only that, also you can also come up with also called the render viewer. You see, it's more like a animation. You can just click it with the mouse and try to view it at any angle. And you can also see all this one also based on the graphic part. So Midas Gen provide what you call the strongest, it's very powerful in terms of the graphic designing. So this graphic design also will help you also in terms of doing your presentation, in terms of explaining your project to other people. And at the end of the day, looking at the color and everything, everybody will like it. Why? Because it's very, very productive. So all these are the graphic part of it. As I say, is very powerful. You can see the result after you've done the analysis. You can check the result there. What are the weak part? What are the strongest part? You see all these kind of the complicated structures. You can see the graphic design. You see, very admirable. So any type of shape, any type, like name it, just isosurface or maybe top and bottom stress. You can just check everything, like the beam stresses or the beam forces. It depends with what you have. You can actually check it within the software. So the graphic part is very powerful on that. As you can see, also is the same part. All these are the high-rise building, the tallest building in the world. The result also after you've done your design, You can check the result there, giving you the numbers, the maximum result, the minimum result. And you see, you're good to go when you have such kind of a software. Now, this is now the very important part. I know most of you have been really, let's say, maybe waiting. Well, after you've done your modeling, you've done your analysis, now you've done your designing part, the software is able to actually give you the feedback based on the designing report. So it can generate the designing report. For example, you have this kind of a diagram. You can actually generate it by just drag and drop. And then at the end of the day, you have something like this one. You see, it's an MS Word file. So you can also put it on maybe, let's say, the Excel file, depending with whichever type you have. And this is actually very essential, because if you want to make any changes, if you made a mistake here, you can correct it, and then it means you can regenerate your model and then regenerate your report. So it means this is very, very essential. Now let's check on the specialization. So what kind of specialization does Midas Gen focus on? Now, this is the seismic analysis and design, especially country like Japan, like Europe, America. These countries have been affected by the earthquake. So these countries have been using our software, especially to do the pushover analysis, doing the boundary and linear analysis, during the fiber analysis and the capacity design. So it means in terms of the seismic analysis and designing, you can actually do it based on Midas Gen. So I know that in Africa also we are not that affected with the earthquake as compared with Japan, but still, if someone want to use it, still you can actually apply for the tall buildings. And also this, we also have the construction stage analysis. For example, like the tall building, you can see you apply the construction stage, you come up with the result, like the column shortening graph, or see all this kind of the diagram, you come up with the result. So it means still you can do the construction stage, and putting the time identity, you are able to calculate the string, creep and shrinkage, and also you are able to actually calculating the what you call the shortening column. So it means you are able to come up with a table like this one, or maybe the result for the creep and shrinkage like that, based with the different types of code that you like to apply. And also you can do also the nonlinear analysis, so like plastic analysis, or the heat of hydration, or the masonry nonlinear analysis, or you can also do the large displacement analysis. So it depends. If you actually have the module, you are able to select like what type of analysis you want to focusing on. You want to focusing on the heat hydration analysis, well and good. It will provide you the report. It will show you the type of the forces and the effect from the strong and the weak, and then you can see actually how you're able to correct, let's say, maybe the mistake that has arise within the analysis. Now let's check on the service then. What kind of service does Midas Gen provide? Well, I will just assure you that when you come to the service, we are very, very concerning with our clients, or very concerning with our users, because we are not just focusing on selling, but we are actually focusing on seeing we have satisfied our client to the maximum. First, we operate 24 hours. Not only operating 24 hours, we actually check on our clients whether they're using the software well or not. So in short, actually, we always upgrade our software every year. So it means for the upgrading part, we try to also to update our clients on the new features of the softwares. For example, like the new implementation for the latest version, we have the pushover analysis, general section, and also the footing design. These are the new, actually the latest version. So we've actually update our clients, try to keep in touch with them, informing them what are the new updates, you see. And not only that one, also, we also give a note, for example, in case of the new update, we release a note to them, informing them that these features have been implemented in this software. So, and then they are able to use it. So it means most of the time we are one with our client. Also, as we provide also training, like we have the online training, we also have the offline training, as you can see from the pictures. Now, those who want to learn, let's say, for example, our software, we always do for free. Like now, what we are doing now, we are doing the webinar that is more interactive. You see, I'm presenting to you. You are there also watching and listening. At the end of the day, you may have question, and we are going to provide you the answer. We also have like a free webinar. Like we can actually provide a free webinar, like recorded webinar. You can actually give us the request, and we can send it to you. Not only that one, also we do the customized, whereby in case, for example, one of you want maybe special topic pertaining to this Midas Gen, we can actually provide that the webinar based on the request of our customers. So it means we actually very free in terms of trying to update, try to pass the education, the knowledge of the software to our clients. And not only that, we also for the offline, many people are coming to our our company, especially to learn the software. We do a lot of seminars like one-to-one. We have the workshops and everything. So all these actually are geared to create the satisfactions and actually to fulfill the needs of our clients, means make them to be very comfortable with us. Why? Because we are not just focusing on selling, but we are focusing also on seeing how maybe comfortable our clients are. So we provide this kind of service, as you can see from there. So it means at the end of the day, you can check from the online. We can actually be able to. You can see many of our projects that are going on, and many people visit also our company, and we have different types of headquarters also that we provide also the training. And now this also is very important because this is the technical part of it. You know, most of you may be worried, may say, oh, after buying this software, and then what am I going to do if maybe I have any problem? Well, I will assure you, you don't need to worry about that one, because we really provide 100% technical support, especially like, for example, if you have any questions, we are able to respond to you. And we organize this one based on seminar or workshop. Also, we have the web-based, like whereby people ask questions, we provide to them answers. And also we have the technical papers whereby you can see from here, we provide, let's say, a technical paper, updating also our clients, sharing with them pertaining to the technical issues. And not only that one, also through seminars, also people are able to ask many questions. We also have our web board whereby people can upload the questions. We are able to respond to them. So it means at the end of the day, we operate 24 hours in the office waiting to hear from our clients. Now, let's look at the reliability. Now, well, as I said before, this software actually has been used over more than 150 countries, and we have like 10,000 license copy. And you see, these are the projects that we've been able to do them, like in China, Japan, America, Europe, and we have several types of building, like name it, like the tallest building in the world, name it. They've been using our software. So it means at the end of the day, it's very reliable, because you can imagine all this, the tallest building, like you see, like the Burj in Dubai. And also there is also an ongoing project that is going on in Dubai now, whereby they're actually designing a tallest building now again. They're using again Midas Gen. So it means it's very reliable because we have very diversity of the project applications. As I said before, also still we have the spatial structures. Let's say speciality of the structures can be stadium, or it can be, let's say, a museum, or maybe airport, name it. Just you can actually apply it using Midas Gen. So it's not just focusing on the designing or maybe analyzing the tallest building, but also different types of structures. Okay, how reliable it is then. So it means, as I said before, we have what we call the MQC, that is Midas Quality Control System. Now, this control system, that's where now, when we have, like, let's say, the bug report, for example, someone has been using our software, he has encountered, let's say, a bug. He will actually report to us, and we are able to report to the MQC, whereby they're doing now the testing and the verification of everything, and they send it back, and we send it back to the client. Meaning, at the end of the day, we have a system that is very organized in terms of tackling bug, in terms of tackling other issues. For example, if we want to release, let's say, new features, or maybe we want to release, let's say, new functions of the software, first we make a plan. We plan for it, and then we do the designing and the implementation, and then we do also the verification, and then we release it. So you can imagine all these 4 stages. We have over more than 100 engineer developers in our company. whereby they're focusing on a different place, on a different area. Those who are focusing on the cyber, those are focusing on the post processing analysis part, or maybe designing part. Those who are focusing on the, let's say, verification. So it means at the end of the day, you are very assured that whatever question that you have, it's able actually, we are able to provide you the right answer, because we don't just give answers just like that, but we have to confirm it. We have to prove it whether it's working or not. So we have the system now of reporting the bug system. For example, you report the bug report. That's an error confirmation report. So we have the bug notification, the bug, we fix the bug, then we send you the patch. And then after we distribute the patch, you are able now to correct the mistake that maybe you've encountered while using the software. So you can imagine, not only selling, but also talk about the technical part. We are very concerning. We have this kind of system whereby we have different types of developers. I said more than 100 developers. So these are the kind of examples, as you can see, like the question that we've been receiving, and also the type of the verification, let's say based on the backlink or maybe anything. So it means first we just plan, then we do the designing and implementation, then we do verification, then we release the node. So I believe you are able to see how orderly we are. So before I proceed, now this marks the end of the presentation for what is Midas and what does Midas Gen do. Now I'm just going to do the demonstration of this steel structure. So as you can see, it has the first floor, the second, it has the fourth floor. So I'm going to actually do the demonstration. I'm going to design these steel structures. And in case you have any question, please, you may just send them on the question board. And these are the applied codes. I'm going to use the ISC and the design code also. You can see the material and the column. And also, these are the unit of the load cases that I'm going to apply. I have the self weight, I have the dead load, live load, wind load on the X direction and also on the Y direction, plus the response spectrum seismic load on the X direction and Y direction. And also, I'm going to add the earthquake on the X direction and Y direction. So I believe after this, we'll be able to be sure what kind of a software it is. So this is the window of Midas Gen, as you can see it from here. On top there we have actually the main column. As you can see, we have the view, we have the structure, the nodes and element, property, boundary. We have the loads, analysis, result, the pushover, design, inquiry, everything. So not only that one, also you have what you call the wizard. You see, you can generate the story, or you can build a generation, just name it. And we have different types of wizard based on this one. You can also apply the loads. You can see different types of load. You can also check the result. You see the dynamic result. You can also do the pushover and everything. So I'm just going to use it to design the steel structures. I know. And then on this side, as I said before, this is the works tree. We have the menu there. I give you the directions. You can see. And also you have the table, you have the group, you have the works there. So whatever I'm going to do is going actually to be recorded here, meaning the step that I'm going to apply, like in terms of the modeling the structure, is going to be shown on this part. So I'm able to follow up the step. And then lastly, I have the report, you see. So it's very user friendly. Not only that one, look at the window model. It's very clear. You just right click it. You come up with what we call the context window. You don't need to go to the wizard there. You can actually just right click it and check everything, just, whatever, maybe it's the nodes, the element and everything, name it. And then we also have the second menu, whereby you can use this one also. Maybe, for example, you're doing very complicated structure. You can save them on the group and try to just do the drag and drop. And also we have the icons here. You see, they're very, very, very useful actually. So you can imagine this window makes your work very easy, meaning it reduces time and it's actually maximize your efficiency in terms of using this software. We also have other icons here. We have the nodes there, we have the elements, just name it. You can do performing the analysis, the pre-processing, post-processing. And not only that, also you have the message window, whereby in case you've done anything a mistake there, it's able to be explained, just give you the message, oh, you've done, sorry John, you've done a mistake somewhere, and then you have to go back again to the work tree and try to check where you went wrong and try to correct it. Not only that, also we have the command message, we have the analysis message. So you can imagine this is all that we have. And the task pane, as I said before, you see, you can import the project, you can open a new project, whichever that you want, give you the direction of the forces and everything. Any type of analysis that you're not sure with, you can actually apply. Not only that, also on the help here, we have the manual. You see, you can just click it about Midas Gen. When you click it, then you have the manual will pop up, then you're able to check it out. And so you are actually assured, means everything you can just do it while you're using the Midas Gen. On this side also, you have the new project you can open, or you can also import, like let's say from other software, as I said before, or from the AutoCAD, let's say SAP program, or just name it. You can also export, not only import, also export. So it make your work very easy. So I'm just going to start by modeling a structure. So what because I'm starting modeling this, I will start from the beginning. I'll just go to the property. I have the material there. As you can see, we have the material section. I'll go to the material. Now you can, for example, if you're going step by step, you can just click it, add, and you have something like this one. Let me just show you. You have something like this one. So you can put, you see, like the type of the designing that we have. You have the steel, concrete, SRS, user defined. You can choose whatever you want. The standard, you have different types of standard. The database, you have different types of database. So it depends. If you're using step by step, you can just input whatever type of design that you want, put the data, the right standard, and you are able to actually start modeling your structure. Or you can also import. Like for example, I'd already prepared my steel structure, so I'm going to import the material. You just click it, import, and you have something like this one. So I'd prepare the girder, steel columns, and the brace. I just click it, okay, it's already applied there. These are the material that I'm going to use. And I'm going to section again. I will also import the section from my model. And I'll import that one from my model. Oh, sorry. So I'll just import it from my model. So it's already, let me show you. It's kind of a little bit, okay. So these are the sections that I prepared. So already I have 6 sections, and I have this one I just created that I'm going to show you how we're going to do the drag and drop. Just click it, okay, and then I have the section there. Then close it. So already you can see from the work tree there, already I've inputted the material. I have also the section, and you can see everything is showing you the step. You see the property and the material and the section. Then I'm going to actually import the model from the AutoCAD file. So you just going to browse it because I'd already prepared it. I'll select it and then add there, click it, okay. You see you have the material as the girder and the section is indicated there. Just click it, okay, pop, you have something like that one. Then you can use the icon on your right hand side to view it whichever you want to see. So that's the model that I prepared it, and I wanted to show you how we import it. So you can use the icon there either to decrease it, or you can zoom it, whichever way you want. So I'll just go direct to model this, to come up with a steel structure. So this is a part of the model. So because from now I'm going to create the column. You see the column. So before I do that, I'll just have to select everything, and then I'll unselect by window because I don't want the column to appear on this node here. Okay, then I'm done with that one. Then so because I want to create the column, and I will just go to to the nodes and element. That's where I have the creating element there. So I'll just go up to that. Then I need to create the column on the steel column. And then I have the section as section 6. And then, okay, before I go to that, I have section 6. Then I have to put, wait, there's something here I've forgotten. Okay, so I have to create there -5. Okay. Before I go to this one, this is something that I've actually forgotten. Let me just. So I have this one. So I have to create the column. So what I will do now, just have the. I have to go to actually extrude, because this is the model. So I have to extruding the column, meaning on either on the minus side, let's say -6 or -5. So I just have to actually go to the extrude. Then I have to choose the type of material, that is steel column, the section as before, the section 6, and then I have to choose which direction do I have to actually extrude the column. Let's say -5. How many times? Only one time. Then you just click it, apply, and there you are. You can see already we've created the column. We have the column. I see you can see it. And another thing also, you can view it from any angle that you want. You see, whichever angle that you want, you can actually view it. So already I have the column, so I don't need this part already. It's already applied there. Now another thing also, you can see the black part, meaning it's already applied. For example, if I click it there, it means it's already applied there. But the blue side means it's not applied yet. So we have to apply it. So I will show you. Let me just unselect it. Now I have the column. So next I'm going to create the brace. So I will select everything again. Not selecting everything, I'm sorry. I'll just select this part only. So I'll select by single. I have it there. And then selecting by single, and then I'll just activate it because I need only this part. Oh, okay, just a little bit. Okay, I made a mistake. Let me just go back. You can actually undo it when you make a mistake. So you can just undo it and come up with your diagram like this. I had made a mistake. Let me just undo it. So what you do, we have to select this part. So I'll just do select it by single, and then activate the part. I was supposed to activate by this one. I'd click another one. So we have this diagram there. As I said before, in case you made any mistake, you don't need to worry. You have this part here where you have undo. You can undo and try to change any part that you actually made a mistake. So I need to put the brace. You can see on this one, I just activated. So I'm going to go to the brace. So I have to select by single. I select this part here. I'm just selecting by just clicking it because I need to put the brace. So I'll select the section for the brace. Just put the section 2, pop. You can see it's changed already. That's what you call the drag and drop. You don't need to start creating it another way. Again, also I'll select again by single this part here and put section 5. You can see it's actually changed. So that's what you call the drag and drop. Then I will actually select this part here and put section 3. Just imagine, just drag and drop up and it's changed. Then I'll go back. So I'll just try to activate all. Then I will select this part again. I'll do drag and drop section 2, pop, it's changed again. Select this part here. Section 4, it's actually changed. So already, okay, this is not included, as I told you, it's just for testing. That is my only, I just put it there just to show you maybe after I've done everything. So let's just confirm already this part is not putted. So let's try to actually put the brace. So already you can see we've actually put the sections. Section have been applied. Now I'm going again to to select by single so that I may be able to input the brace. So I just activate that one. Okay, I'll just use you can actually shrink it. Now, so already we are going to create the brace. So for the shrink, you see, you click this part here. You can either make it to look like that one, or you can shrink it, make it your work easier. So because I'm going to create the brace, I need now to go to the nodes and elements where I have the creating element there. Now, this time I already used the gather, the state. Now I have to use the brace using the section 5. So I'm just making the brace. Just click it. I use this diagram because it's makes your work very easy. That one there, just click it. From there you have it. Okay, you can see already we can view it. You see, let me just make it. Okay, you can see it. We've already made the brace, but still I didn't apply. I need to apply also on this part. So I'll select by single, then drag and drop the brace on this part. So it means now everything is actually applied. So I'll just activate all and try to show you now, confirming our gather, it's already applied. The steel, you can see the column there we made. The brace, you can see the brace that we made already. And then confirming on the section, we have the section there, section 2, section 3, section 4, we have section 5, and lastly section 6. You see, so I want to unselect, just right click it, and then you just do the unselect. So already we made the model. Now we have the model. Now everything is actually applied. So it means now we just move to the next step. You can see the work tree give you the direction. As I said, you already input the sections. You have the material. Now, which next step where you are supposed to go? Now we are now going to generate now our building. I'm just using the building generation. First, I will select this one because I need to generate it, let's say, up to the 4th floor. So I will select everything, select all, it's selected. Then let's choose the number of copy, just only one time. The distance, I will choose 4, and then just click it, add, then apply. You can see the building is already generated. So how many times do you want to generate the building? You can just put the number that you want, for example, 10, 17, 18, name it, it's up to you. Okay, this one tells me I have to save my model, so I'll just save it like that. Okay, so already we have that one. So what I'll do now, I'll just create I'll generate other type of building. As I showed before, we need to create it. Select that one by single, try to check it, and then because I need to generate only this part here, so I don't need this one. It has happened like this one. You don't need to hesitate. We have an icon here. It's called unselected by window. Just click it. We just drag like that one. It's unselected. See, not difficult. You see, it's really easy. It's very easy to use it. Then you go back again and select again by single because we need to generate this part here. And you can see, so we need to generate this one. So you're going to use the same condition here. Just click it, apply, boom, it's already applied there. So already you can see we've generated the first floor. We have the second floor here. I didn't need this part here. I want to focus on this part only. So you can see you can view at any angle that you want. Okay, we continue. So because we have to create up to the 4th floor, so just go to the view. Then we have to select to the left hand side because we have to generate other part also. So just select this one. You can see there. So I just need only this part. I'm going to generate it again. So I just click it, apply, boom, there we are. So you can bear with me. This diagram looks like the picture that I showed you before. I think you can remember. That's what we wanted to generate. We wanted to actually to model already. We've modeled it already. So you can see, you can view at any angle, up or down, sideways, whichever way that you want. So you can see looks the same as the picture that I showed you before. So already we've modeled, we have done with the first part of modeling. Now we go to the second part whereby we've generated already the floors. So we're going now to put the boundary. For the boundary, you can right click it using the support, or you can just go to the boundary and define the support to just pop up the same thing as this one. So we have to select to put the boundary at the bottom there. I have to select the bottom part, select by single. After selecting, then you have to like constraining the boundary, the direction on the X or Y, Z, just the rotation also, just constrain all, then apply. There you are. You can see the boundary have also been applied. You can also view it at any angle that you want. So you can also see from the work tree again, it shows you the boundary actually they've been applied. So when you click it, it shows, oh, it's already applied. You can actually unselect it also, unselect all, and yeah. Then after you've applied the boundary now, so what you're going to do now, we're going to do the diaphragm disconnecting. We just have to, first of all, we have to select this one. We select the center part, select by single, and then apply. You're going to actually to apply the diaphragm disconnecting, click it up. So it means it's already been applied on this area. So everything you can view there, the nodes, blah, 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 blah. We have up to 165. So everything has been applied. Check on the boundary. As I said, you can just display. You have the boundary there. You can undisplay it also. The diaphragm is there. So already we have generated the building. We have put the boundary. Then let's try to generate the story. Let's say auto generation of the story data. You can see we have the first floor, the second floor. It actually gives us whatever we've inputted there. Third floor, fourth floor, and the roof. So you just click it OK. You can see there the type of the name, the level, the height, and the floors. You can check the wind, you can check the seismic, and yeah. So let me just unselect that one. So already we've generated that one. So next now we are going to actually input the loads. So we're going to have the static load. I'll just put first of all the self weight. I know most of you know this one. It's a dead load. Just click it add. Next I'll just put the dead load. Same the dead load. Then live load. Just click it, this one live load. You have it there. Click it add. And you can see before we had said also wind load on the X direction. Wind load, there we have it. Again, also we have to put the wind load on the Y direction. Still we have to put also the what you call, I said the earthquake. I'll put the earthquake on the X direction because these are the tall buildings. So we go to make sure that everything is applied well in the X direction. Then again, as I put on the X direction, I'll put also on the Y direction. Okay, so already we have our load there. As you can, you've seen before, we have the self weight, dead load, live load, wind load on X direction, on Y direction, earthquake on X direction, and also on Y direction. So we just close this part here, and you see the work tree again. As I said before, whatever you input, it actually gives you the direction of everything. You see, I've already inputted there. It's already applied. Then I'll just put the self load. Put that one to -1. Click it add, then close it. So the self load, self weight, you can see it's there also already. So we already inputted the load. Now what you're going to assign now is the flow load. We go to assign the flow load here. So before we define it, we just have to assign it. Now for the flow load, we have the flow for the first flow, or for the first flow. Okay, for the first flow load, Oh, for the first floor load, we are going to put the dead load, say minus 3.6. We're going to put the live load minus 3.9. Then you click add. It's already been added there. Then we're going to have what you call office. Then office, I'm going to put second to third floor. That's for the office. I'll put there, let's say minus 4.2. This one minus 2.5. Then click it add. It's already added there. Then finally I'll have the roof. So I'll have there the roof load. For the roof load, I'll put this one 5.1. This one minus 2.0. So everything is, we have the floor load there. We have office, we have the first and second office load. Then we have the roof load. So it has already been applied. Now what I'm going to do now, I'm just going to apply the floor load on this structure. So we have this feature where we activated by identifier. You can just do Control D. So it's the story, the second floor. Let's say below plus below, then activate it. So we're going to activate it and then close it. Okay, you can just shrink it. You can just hide this one, put in this format. So we start with the floor load. So just go to the node defining load area. Just define it, tap. As you can see, we are inputting the floor load here. You have something like that, you see. It looks very admirable, isn't it? So it means they've already been applied. Then still we are going to also apply on this part here. There you are. So let me just activate all. You have something like that. Let's look at that. You see, first floor, it has been applied already. Now I'm going to select on the second floor, that's the office load. Select by single, then just activate it. Pop. Now we're going to apply also for the office, so we have to change the load type. That's the office. Now you remember we put the second to the third, so we got to put that one 4. Then defining the loading, just go to define it. That's our office. There you have. Next. There you have. Then next, this is the office. You know, we have the second and the third. So already we've applied, and then I'll change this one to the roof load, the remaining part now. Just apply there. It's already applied. Let me just activate all, and you can see it looks very, very nice. You see, you can see the second floor has been applied. Let me just show you. See, the second and the third floor has been applied for the office, and you have the roof here. Then finally, also have to create the roof load on the top part here. Select by single. Then you go to activate it. There you have. Still is the roof. Just select it. You can see it's not that difficult to actually use it, Midas Gen, because everything has good directions. Just to follow the direction and you're good to go. There you're done. So let me just activate all, and then you may be able to see that everything has been applied correctly. You see, we have the first floor, we have the office for the second and the third, and then lastly is the roof plus this roof. So it means everything has been applied correctly, and that's our diagram. We've already inputted the loads, we have the boundary, and we can confirm everything. Like for example, when you come here, you can see here everything. You can just confirm everything from here. Sorry, you have this one already. we've already put it. You can confirm it there. Check the flow loads. Just right click it, display it, boom, you have it there and displaying it. The same also the flow loads, display it, boom, you have it there. So you can just actually check everything, whatever you've put, the boundary, as I said before, display, and then you can actually undisplay. So already that's our diagram, and we've actually put the loads. So now we're going to add what we call the wind loads. As you remember, we actually input the wind loads. So going to add that. So wind load on the X direction. Remember the codes was for the 10. Change this one to 125. Because it's on the X direction, okay, just click this on opposite. So we don't need 1, just put the Y 0. Then you can actually put, you can click the wind profile. You come up with this one. You see, it gives you the component on the X direction, the profile, story force. You can see the wind forces there. You can also actually check the table there, giving the result, the pressure load, the blah 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 blah, everything. You can also come up with the load case sheet, something like this one. So it's more of a report, you see. It gives you the wind loads, the information, you can check everything there. So you can actually use this one as a report. You can save it, or you can also you can actually print it out. So it gives you the designing wind loads, give you actually the formulas, the area, the structure rigidity, and everything. So it depends with you now. So already we've confirmed that one. So I'll just say click it. So already we have on the X direction applied. It's already applied there. Now next, as you know, it's on the Y direction, the same code. So I just have to change this part. 1, I don't need the X, 0. Same result, just click it, okay, and it's already applied there. Close this part. Now let's go back to the structure and try to confirm whatever we've put it. So our structure type is a 3D. And then looking at the mass control parameter, you can see there the lumped mass. You can, for example, if you want to consider of diagonal masses, you can actually select it by yourself, or maybe consistent mass, or maybe just depending with whatever you want. So for example, I want to convert the self weight into masses to xy, then aligning top beam section with the flow on the xy plane, or you can also align on, it depends with you actually. So it means you have everything there. Just click it, okay. It's already applied. So next I'm going to apply, we have the wind load there. So I will apply now the seismic load, that's the earthquake load. Click it, add. Remember that on the X direction, the code, we have it, the code there. Change this one to 0.745. Same also to this one, 0.745. And then since it's on X direction, I don't need that. I just put 1 positive and then confirm it. So this one also the same thing. Also you can see the profile also. The component X direction, the story, you can check all these on the table. You have the seismic forces, the earthquake forces on the X directions. You can also generate this sheet here. So the software, it's very reliable because it gives you the information, you see, based on the earthquake, on the story, the masses and everything, additional masses. Or you can see all these, just very, very, very efficient for the engineers. So you can also print it, or you can also save it. You can use it for other calculations. So click it, apply. You can see it's already applied there. Now I will apply also on the Y direction. It can 0. We have 1 there. So it's the same thing. It's already applied. You can see already we've applied, so we can close that one. So we did the static load. So we had the wind load and the seismic load. Now next we just have to do is the dynamic load. That's the response spectra. So click it, that one. We have add there. So we have the designing spectrum. We check the code, confirming the code, and everything. That one is okay. Maximum. You can see you have the diagram there already, and you click it, okay. Close the part. Then check on the load cases. That's a RS, as you saw before. It's auto search. Put it to the major. We've selected this one, so you can also check information that is put for the model combination type. You can choose either ABC or the linear. So I just chose that one. Next, you need to actually accidentally for the eccentricities. So this one also we need to confirm it for the eccentricity accidental. So that's 5. I think that one is be okay. Then we now check on the eigenvalue analysis control. Now we have types of analysis whereby you can choose any type of analysis that you want, or it can be either this one or it can be this one, depend with whatever you want. And the number of frequencies, for example, I'll prefer 10. Click it OK. Then we're good to go with that. So once again, let me just confirm it on that. I did the right thing. Let's say we have RS, then auto is major, then confirming that one, then accidental, then we need to add. I didn't add that one. I'm sorry for that. So we need to add it so that it may be able to be. You see, like before you've seen the blue sign. You see, this one was blue, meaning it was not applied. So it means there's a place where maybe I went wrong. That's why I had to go back again to this one to try to check where I went wrong. And I realized I didn't add this part here. So that one is okay now. So it meaning everything it's already applied. So you can see the work tree gives you all the informations, and you can imagine, name it, just whatever you want to click it, you can display it, you can undisplay it. You see the type of the wind load that we put it there, we can display it, you can see it's there, or undisplay it, static load, display it, you can see it's already. So it means everything that we put it's already implied on the diagram. And that's our model already. It has the loads, all types of loads. Now, I guess now it's time to run the analysis. Now let's check on the message on the window here, what is going to come out in case if I made a mistake. The software is going to tell me where I made a mistake and I have to correct. So let's see how long it's going to take. Oh, it's finished. That's I guess, is it 1 minute? I think it's less than a minute. I'd say 10 minutes, but it's not even 10 minutes. It's like less than a minute actually. It's like 2 seconds, maybe 3 seconds. So you can imagine the analysis is done. And this is something that when you just tell other engineer to, let's say, do the analysis, they will take a lot of time. Let's maybe tell them to design this one. They will also do it manual, take almost like maybe 2 weeks or maybe even 2 months. So you can see from here, this is, we perform the analysis. Now this is the pre-processing where we are doing the modeling. Since the analysis has been done, now we are on the post-processing. So it means now we can now check our result. Now on the result, we click the result button. We have the reaction there. We check the reaction, let's say on that is self-dead load. Check the value and the legend, click it apply. You can see it shows you now that this part is the most like the maximum force. You can see from there, and the minimum force. And these are the legend. It gives you all the types of the forces applied on a different direction, on the X direction, Y direction, Z direction, or the combined one. Not only that one, you can also check the deformation. Maybe I don't want to check the value. I just click it, legend, and then just click it apply. You can see it has already deformed. If maybe I might put the value, you may see how it's going to appear. That's how it's appearing. Now from here you can see this is a picture. You can generate your dynamic report from here, or you can generate the table from here. So it means whatever you want, you can just come up with. Then force, let's check the force, the beam forces applied. You can see it gives you the maximum up to the, let's say, the minimum. You can see the maximum and the minimum. And for the engineer, you can know where to focus on when you look at this diagram, you see. Then let's look at the beam diagram. Beam diagram. So you can also increase the scale maybe for the, let's say if you want to put, for example, I want to put here 2. I'll put there 2. I'll put there 2. See how it's going to, see, it shows you now clearly, you know, the scale, as you know, the scale factor, you see. So you can see from there. Let me just remove the value. See, Now this is our diagram. You can see those are the beam, so you're able to come up with a result, such kind of result. Let me just reduce it to 1 to make it more clear. And then we can also check the beam diagram. We've checked. We can check the stress, the truss. Let's say the beam stress. Apply the beam stress. There we have it. Check the result. There you have it. Okay. Then let's go back to the beam diagram. Check on the solid part. As you can see, it's very, very interesting. You see, very, very interesting. Meaning everything has been applied. You can check the force on whichever way that you want. Now let me just do the load combination. Since we are dealing with the steel designing, so we have to do the auto generation, confirming the designing code. That's our designing code. Click it OK. It's generating there. You can see it's there. Just have to close it here, and then once again let's check the load combination. You can choose any. Just apply it there. You can actually choose let's say for the line, let's see, something like that one. So you can come up with a table, or you can generate the dynamic report. Then when you are finished on already checking the result, you can now check what you call on this the result table. Now you can check your table there. Let's say I want to check the load case on the dead load. You have the table there, as I showed you on the presentation. These are the total forces that have been applied. You can check on any direction, X, Y, Z, or the moment. Or you can also check on the beam forces. As you can choose maybe any type of the load case. It come up with it. You're able to select it, and you can actually copy this one, whereby you can export it to the Excel file. And then next, I want us to check on the story. Like I say on the story, you see, we have the story drift. We have also different types of results: story displacement, story shear. So it depends what type of the result that your area of the project is focusing on. You are able to check the weight irregularity check, overturning moments, talk about the stiffness irregularity. So let's start with the drift. So I'll just select these three. I'll have that one. Then just put 0.02. Click it OK. I can see there it's already applied. It means everything is okay. You have the value and the flow, the type of the load case that I've selected, the live load, dead load, and the self weight on the flows. You have the value there, and the ratio that I put was 0.02. It's already indicated there. The scale factor is 1. Still, also you can check more things actually. You can check the weight, let's say for the response spectrum, earthquake. See, you can come up with this table. As I said, you can export to the Excel file. Now you have the red part. This one means it's not well applied, it's not safe. But this one, the blue part, means it's safe. So it means now for the engineer, when they look at this kind of a report, they have to go back again and try to correct, let's say, the weight that they have actually inputted, and check maybe what is actually the mistake. So you can also copy it, or maybe you can export it on another MS file. Then still you can also check on that was you can check on the irregularity, or let's say overturning moments. Whichever load case you're choosing, you're able to check the result for that. Click it apply. You can see some of the forces distance, the overturning moment we're given there, the angle and everything. So the software is really automatic. You can imagine you've not used a lot of time to come up with this kind of a report, so you're able to be sure with. So you can save it, and you're able to use it maybe for other engineers. So as I said, for the story, you can check all this type of the result. There are more depending with what you want. So I just want to focus again on the designing part. That is the last part that you're going to check it. So for the designing, we have the code there. Choose the code. What type of the code? As I started before, that was the code. Then design code. Let's confirm it. That's the code. Then select it. Select that one. Then the system. What kind of system? I will just use the intermediate moment frame, or I may use that one. Click it OK. Now you can go this diagram, you can actually go back again to the initial view. This is how it appears. Then check the general design definition of the frame first of all. Okay, we have either unbrace it on S-way or maybe brace it. So it depends with what you want. You can actually select from here. Then auto calculation effective length factors. If you want that one, you can do it. Click it OK. Then you have what you call modify the live load reduction. So we need to modify that one. Let me just put that one to 0.8. 0.8. Then I have to actually select this my diagram on a front direction. I go to select by single. I need to apply it on this part, on this part. So all forces need to be applied on that one. As you can see, it's already applied. Then I need to apply also the remaining part. Just selecting by single is not that difficult. Then I need all forces. This time I'll just use 0.9. Click it applied, and everything has been applied. So you can see the force load has been reduced. You can actually see the value from there. You can view it at any angle that you want, bottom, top, or maybe whichever way that you want. So after we've done that one, we go back again to the designing. So we're done on that one. Let's go to the second part. Let's confirm it now. The strength reduction factors, these are the value that we imported. Then click it OK, make it everything, it's be OK. Then still now we can check on the table. You can check the table, or now you can check the still code check. Let's check on that one. You can see it's running it. Member checking the members, and there you are. So this is now for the you are able to check the result. You can see there the members that have been applied. Everything is okay. So sometimes it may be indicating on a red color, meaning it's not safe. So you have to correct it. Maybe I'll show you. So first of all, let's check on this. It means everything is okay. So let's check the graph part of it. Okay, first we have to select. You see, when you click like that, it means not selected member. So you don't need to panic. Go back there, then select all, or you can just unselect it. So maybe I just want to check from each stage. So just click it, and imagine you come up with something like that. So you have the designing information, the type of the code, member numbers, material, sections, forces that have been applied, designing parameter, checking the result, everything is okay. Sometimes it's not okay, so you have to actually change it. I'll show you how to do that one. So that's one. You can check the detail report. This is very efficient. You see, Midas Gen, still code, blah, 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 blah. The type of the code that you've used, Midas program. What kind of program have you used? That is Midas 2015, because you have different types of like the year. Then information is there about the Midas. You can check it out. You can check the definition of the loads. You see, you have the still code checking. You have the still the same also thing. So you come up with this kind of a report actually, and it's very, very essential for the engineers. So in case maybe, for example, you have, let's say this part is ready part. So first you select it. After selecting it, you go to change. When you go to change, you have this kind of a button, or with this kind of a dialog here. You search by specifying section. So for example, you come up with this one. Then you select the section that is okay. You click it, and then you change and close. Then when you change and close, it will take a little bit of time. This maybe, yeah. So when you change and close, then it will show you like already it has been changed. So then you can now go to the update and try to check the update, and you can actually recalculate, or maybe you can run the analysis. So it means if you made a mistake, maybe there is the red color here, you don't need to worry about anything. You just go to change. You change it, just follow the step, and you find it's not that difficult. So so that one is now, as you've seen from the initial, we were able to generate the report, the designing report. You can see it as you've seen it. Not only that one, also we also had this one also. It gives you the diagram for it. So it means, as I said, you have to select it. Sorry, maybe you want to select all of them. Let's say select all. Come up with a report. So this is, you see the diagram, you have it there, definition and everything. So you're good to go when you have this kind of designing report. So you're done with that one. Let's just close it. Then finally, we're going to check on the what you call the still optimal design. You can see it's already checking on that, and then poop, it's coming up. You can see the number. Now we have to select all. It gives you the size, the section that we've actually inputted, the size of the section, the area, the designing criterion, see, and so on and so on. Then analysis options. So this is very important because it's like doing the optimal. It's need to come up with an optimal result. So you can put 3. It runs the first round, the second round, and the third round. Then you can compare the second and the third. You get the optimal result, and then that becomes the perfect result. Click it OK. Check the column design. These are the column design that we have it. You can see it there, external and internal. Then now let's run our design analysis. We did how many times? We just said it's 3 times. Okay, so it's going to run the analysis for 3 times for this designing. You can see there the process. That's the first one. So the red sign means it's kind of is not that safe. So it will give you, that's the first time, meaning we have that one. Still is running the second time now. You can see the multi-solver front, as we said, it's very fast and very accurate. You don't see any crashing of the software. So that's the second time. Now it's going to the last part. Then it will come up with the tables to show you for the first round, the second round, and then the third round. And there you are able now to be sure now everything is done. So it's still running it out. You can see. So the multi-frontal solver and the algorithm is really fast. You see. So for the first one, this is the first part. You can see. I hope everybody can see that. You see, we have kind of many parts that are not safe. The second time, when it runs the analysis, it's only this part. The second part, the third part, again, is the same. So that means this becomes the optimal. So let's we can generate the graph report. Comes up with a lot of tables. And also we can also generate the text report. Let me just save it that. So first, let's look at the tables. Okay, so now I don't need that one. I'll close it. See for the first time, second time, and the third time. See, for the second and third is almost the same. You can see from the graph there. The first one was a little bit. You can see it has a lot of unsafe sections. Now that was the first graph. Now using the line now there, you can see this is the original graph. This is the original sections. After running the analysis, you can see the result also is there. Also applies also with this one. The second and third is almost the same. Then the first one was a little bit, had a lot of kind of unsafe section. So imagine after doing the designing, you come up with the table result. Then finally, that is that marks now the end of our presentation. And before I finish, I would like to actually thank you for your time. And I want to say once again, thank you so much. Now you've been able to see you've been able to see our softwares, what it can do, and then so in case you have any question, as I repeat, please feel free to ask us, and we'll be able to actually be able to respond to you. I can see now some people have been asking questions. So I hope it was a good start, especially for the for this part of Midas chain. So I'm going to send you the presentation, the PPT on the PDF file. I'll check your email, then I'll send it to you, and also I'll send you the record file. And if possible, I'll also send you the trial version to try to use our software and see how you can actually come up with a come up with a model. So you may use our email. We have the email there. We have our website that's in.midasuser.com. We also have our email for esupport@midasuser. You may actually copy down the email. Also, I have my email there. It's elinami0616@midasit.com. Any question that you have, please, you may just actually send it to us and we'll be able to get back to you. So for now, for those who have asked their questions, so we're actually going to send it back to you. We'll respond back to you. So thank you so much. And this marks, okay, before I finish, maybe if anybody has a question, please, you may just send it to us. So I hope you're copying our website and the email that you may be able to reach us, and we'll respond to you. So we are going to answer your questions by email, as I have an email for each and every person. You don't need to worry about anything. We are going to respond to you as quick as possible. And hopefully, we are going to organize another webinar that is next week. We are going to cover the webinar for the bridge design using our software again, another family software called Midas Civil. I'll also send you the feedback and also send you the link. Those who are focusing on the bridges also, you may be able to apply. I really appreciate for that. Okay, thank you so much. Thank you so much for your time. Oh, by the way, I've forgotten something. You go to our website. This is the website, and when you go to this one, you can actually download the trial version. So please, just it's a simple task. Just go to the website, download the trial version of Midas Chain, and try to use it on your free time. In case you have any let's say complicated, maybe any problem, you may actually ask us, and we will actually respond to you. So please, everyone, please just try to download the trial version on this website here and try to use it. You have only 1 month to go through the software. In case you have any difficulty, don't hesitate. Just feel free to ask us. Thank you so much. Thank you so much again for your time, and have a good day.
Muted.